Hello champions, welcome to the channel, and in today's video we are going to do the complete revision of physical chemistry with top 50 questions from physical chemistry. So please just watch this complete video because I'm going to cover all the important questions, all the important concepts so you can easily revise. So let's get started with our question number 1. So the first question here is delta G in the reaction Ag2O gives 2Ag plus half O2 at a certain temperature is minus 10 kilojoule per mole. Pick the correct statement here. Now since this is a negative delta G, that means the reaction will happen automatically, means the reaction will happen spontaneously and Ag2O will get converted to Ag and O2. So the correct answer here, option number A, that is Ag2O decomposes to Ag and O2. Next we have, from the given data find the value of Cr3 plus 3 electrons gives you chromium. So here I have a equation like this. You have Cr plus 3, okay, then it gets converted to Cr plus 2 and this one gets converted to Cr. And if you see here, the number of electrons involved is 1 and the value of this one is 0.424 and the value for Cr2 plus 2 Cr is minus 0.9 and this value from Cr plus 3 to Cr is around that is what we have to find out. And here the number of electrons involved is 3, here the number of electrons involved is 2. Now what you have to do, let this one be 3 1, okay, so 3E1 is equal to, here the number of electrons is 1 plus 3 2 plus 2, so 1 into this much, so that is minus 0.424 plus 2 into 0.9, that is minus 1.8. right? Now if I add these two, how much I will get? So I'll just add here. So I will have 4 2 8 plus 4 12 2. So I'll have 2.224 is equal to E1, 3E1. Now if I divide this one, you will get minus 0.37 21 112. Again we will have 3 4s, so 0.741, which is option number A here. Next question, for the reaction 2NO2 gives you N2O2 plus O2, the rate of expression of dNO2 by dt is equal to K into NO2 to the power of N, where K value is given. If the rate of O2 is formation is this much, then the molar concentration of NO2 is. Now here if you see the question, okay, just let me check if I am able to record it or not. Okay, now let's move to the question here. Just give me 1 minute. Yes, so now we have this reaction, we have minus 1 by 2 of dNO2 by dt is equal to dO2 by dt, right? And we also have dNO2 by dt is equal to K into NO2 to the power of N. Okay, now we have to find the concentration of NO2. Before that, I have to find the rate of disappearance of NO2. Now this is equal to, I can multiply this 2 here, and dO2 by dt is 1.5 into 10 to the power of minus 4. So that gives me here this one 2 into 1.5 into 10 to the power of minus 4. That gives me 3 into 10 to the power of minus 4 here, right? Okay. K into, now if you see the units of K here, mole inverse, liter, second inverse, that indicates that here it is a second order reaction. So I'll just put the value of K here, which is 1.5 into one second, sorry, the K value here, I'll just erase this one. So what is the value of K here? 3 into 10 to the power of minus 3, right? This is 3 into 10 to the power of minus 3 into NO2 to the power of N. Now this one got cancelled, so we have 10 to the power of minus 1 is equal to, this is second order reaction, so I will have like this. So I can write NO2 is equal to root over of this one, or that is equal to 10 to the power of minus 1 by 2. Okay, so that you can write it as like 10 to the power of minus 1 plus 0.5, right? That will give me 10 to the power of minus 1 into 10 to the power of 0.5. Okay, now which log value is around 10 to the power like 0.5, something like that you can calculate. So if you see here, log 3 value is somewhere around 0.475. okay, so it is 0.47 is very close, so this one will be 3 and into 10 to the power of minus 1, so somewhere around 0.3 should be my answer. So I can see option number D here. Next question, 1 mole of an ideal gas expands at constant temperature of 300 Kelvin from initial volume 10 liter to final volume 20 liter. The work done in the expanding of gases. So work done, we have this formula minus 2.303. 1 mole is there. R value is 8.314. Our T is how much? 300 Kelvin. Okay. And log of V2 by V1 20 by 10, so I will get log 2. Now you can see 2.303 into 8.314, it will give me 19.1 into 300 into 0.301. So that will give me 3 ones are 3, 3 nines are 27, 3 ones are 3 plus 4 27, 5. So I will have this one 5730 into 0.301. Okay, so I just take 3 here, so I'll get 3 zeros are 0, 3 threes are 9, 3 sevens are 21, 15, 16, 17, 1719 something. And here you have so how much I can say, just a minute. So that is, here we have negative number and there is 1.3 I'm calculating, so there will be one decimal place here. So that gives me option number B is the nearest answer. Next question number 5 here, 9.65 coulombs of electric current is passed through fused anhydrous magnesium chloride. The magnesium metal obtained is completely converted into Grignard reagent. The number of moles of Grignard reagent obtained is. So first of all, we have to calculate how many moles of magnesium got deposited. That much amount of Grignard reagent will also be forming. Okay. So if I want to calculate here, we have this formula. I can write Mg2 plus 2 electrons gives me Mg. So I can say that 2 Faraday gives me 1 mole. Okay, or 2 into 96500 coulomb gives me 1 mole. Then 9.65 coulomb will be how much, or how many moles it will give me? So that will be 1 divided by 2 into 96500 into 965 into 10 to the power of minus 2. This got cancelled, it is 10 to the power of 2, this goes up, 1 by 2 is 0.5 into 10 to the power of minus 4. Now that if I just arrange 5 into 10 to the power of minus 5, which is option number C here. Next, the solution has an osmotic pressure of this much at 300 Kelvin, its concentration would be. This is very simple. We have this formula, pi is equal to C into R into T, where C is molarity. So we want to find the concentration. So that will be pi divided by R into T is equal to concentration. So pi is 0.0821 pi is 0.821 atm, right? And we have R value is 0.0821 liter atm mole inverse Kelvin inverse, and the temperature is 300 Kelvin, right? Kelvin inverse get cancelled, atm get cancelled, and when it goes up we will get mole liter inverse, which is the unit of molarity. Now if you see this one 0.821 by 3 zeros, and so I will get this one as 10, right? 10 and 300, 10 by 300, so 1 0 I can cancel here, so again I will have 1 by 30. So 1 by 3 if you see is 0.333, and then again 1 0 divided by we have 110, so I'll get 0.03 something, which is option number C here. Next, for a first order reaction A to P, T half is 10 days. The time required for 1 by 4th conversion of A is. This is again very simple question. So we already have T half. So what is the value of K here? 0.693 by T half. Okay. Now the question is asking here time. So we will have 2.303 by K. K is 0.693 into 10, right? 2.303 by K log of, okay. So you can see the values are given in terms of ln. So we don't have to multiply here 2.303. So what we can take here is, one second, we will take just 1 by K. So it is like 1 by K. And if you see that 1 by 4, the time required for 1 by 4th conversion, okay, so that means you have 1 by 4th has already converted, then remaining will be 3 by 4. So 3 by 4 if I write, it will become 4 by 3 here, like 1 by 3 by 4, that becomes 4 by 3. Now if I just arrange this one, this will be 0.693 by 10, so 10 goes up here, ln of 2 square minus ln of 3. This can be written as like this. Now this gives me 10 to the power of 0.693 into 2 times of ln of 2. Ln of 2 is 0.693. So 0.693 into 2. 2 3s are 6, 2 9s are 18, 2 6s are 12, plus 1 13. So that gives me 1.386 minus ln of 3 is 1.1. So I will have 1.1. So that gives me 0.286, right? So I will have 10 divided by 0.693 into 0.286. So if you see 2 3s are 6, 2 9s are 18, 2 6s are 12, plus 1 13. Okay, this is different. So I can write this as 2.8. Okay, and 0.69 will be somewhere around equal to 0.7. So I will get 7 4s are 28. So somewhere answer will be near to 1 4. So that is why option number B here. Next, an organic compound C and H percentage is in the ratio of 6:1 and C and O percentage is in the ratio of 3:4. The compound is, now see, CH percentage is given 6:1 and CO percentage is given 3:4. Now you can see the carbon is common in between them. So you have to make the carbon constant here. So we will multiply this with 2. So it will become 6 and 8. So if I multiply 2 here. So now if I see the ratio of CH and O, it is 6, 1 and 8. Okay, so what is the total mass here? 15 here. So if I see the percentage of carbon, it will be how much? 6 by 15 into 100, right? 6 is the mass, like carbon, and total is 15. So 6 by 15 into 100. So 3 2s are 6, 3 5s are 15. Then I have 5 1s are 520. So carbon percentage is 40 here. Now if I want to calculate the percentage of hydrogen, it will be 1 by 15 into 100, right? So again here I will have 5 3s are 15, 5 20s are, so that will give me 6 are 18, 6.66. Next, if I have here the percentage of oxygen, it will be 8 by 15 into 100. Okay, so that will give me 5 3s are 15, 5 2s are 20, then 160 divided by 3. Okay, so that will be equal to 3 5s are 15, 153 again. So 53.33 will continue here. So if I just want to write down these elements now, C, H and O, carbon percentage is how much? 40. Hydrogen is 6.66. Oxygen is 53.33. So this divided by 12, if I do 12 is a 36, 4, so I'll get 3.33. Okay, now this one 6.66 divided by 1, you are now converted into number of moles. So just divide by 12, divide by 1, and this you divide by 16. Now if you see 16 3 is 48. Okay, so that will give me again 3.33 here. So what is the simple ratio? 1 to 1. So I will get CH2O, which can be written as HCOH or HCHO. Okay, that is option number A here. Next, the correct order of increasing H3O plus concentration in the aqueous solution. So, stronger the acid, more will be the H3O plus concentration. So, first of all, if you see H2SO4 should have the highest concentration because it is a strong acid. So, in which option we have H2SO4? Here also I have H2SO4. Here this is wrong and this is wrong. Now, after that I need to have H2S, and here also I have H2S. After that, the NaCl is a strong salt, so its pH will be around neutral pH. So then we have NaCl, and after that lastly we will have NaNO2. Okay, this order you should know. Next, we have calculate the extent of dissociation if the equilibrium pressure P for PCl5 gives PCl3 plus Cl2 is numerically equal to 3 times of Kp. Okay, so PCl5 is there, it is decomposing to give you PCl3 plus Cl2. Okay, now what we can do, let's assume that this is 1, this is 0, this is 0. Then we will have 1 minus alpha, this is alpha and this is alpha. So what is the N total here? N total is 1 plus alpha, right? Now what is the mole fraction of PCl5? That will be equal to 1 minus alpha by 1 plus alpha. Okay, now what is the mole fraction of PCl3? Sorry, mole fraction of PCl3 is alpha by 1 plus alpha. Mole fraction of Cl2 is alpha by 1 plus alpha. Okay, now it is saying that the equilibrium pressure is P. So what is the partial pressure of PCl5? Partial pressure of PCl5 will be the mole fraction of PCl5 into the total pressure. So 1 minus alpha by 1 plus alpha into P. Then partial pressure of PCl3 will be alpha by 1 plus alpha into P. Next, partial pressure of Cl2 will be again alpha by 1 plus alpha into P. Okay. Now we have to find that what is the value of Kp here. Now if you see, Kp formula will be PCl3 into Cl2 divided by PCl5, right? Now what I can write here for what is given the value, calculate the extent of dissociation if the equilibrium pressure P is numerically equal to 3 times of Kp. So we will substitute that letter. This P that we are using is actually 3 times of Kp according to the question it is given. Now let us substitute the value. What is the value of PCl3? I have alpha by 1 plus alpha, and you can see this, both the terms are same, so it is alpha by 1 plus alpha square into P square divided by PCl5 is how much? 1 minus alpha by 1 plus alpha into P, right? Now what will happen? We will get alpha square and 1 plus alpha square. Then this goes up. I will have 1 plus alpha and I have here 1 minus alpha. Okay. Now this one will have P square and we have P in the denominator. Now what will happen? 1 plus alpha will get cancelled, and in the remaining part we will have 1 plus alpha and 1 minus alpha. A plus b, a minus b is equal to a square minus b square. So I have alpha square by 1 minus alpha square, and here I have p. Okay, p square will be p is equal to kp. Now I can substitute this p as 3 kp, right? So what I will do here, so I'll erase the above part so that I can use this space. Now what is the question saying? That the equilibrium pressure is actually equal to 3 times of Kp, right? So whatever P we are having in the equation, that I can substitute as 3 Kp, and from both the sides now Kp can get cancelled. So if you have this one, that is alpha square by 1 minus alpha square, 3 Kp is equal to Kp. Okay, I'll just see once that I have got the correct values here, P square, and here it will be P. Yeah. So now Kp will get cancelled. This I have 1 here. So now you can multiply 3 alpha square is equal to 1 minus alpha square. So this side it comes here. So that gives me 4 alpha square is equal to 1, or alpha square is equal to 1 by 4, or alpha is equal to 1 by 2, or 0.5, which is option number A here. Next, at 40 degrees Celsius, the total vapor pressure of methyl alcohol and ethyl alcohol is given by this equation. The vapor pressure of pure ethyl alcohol and pure methyl alcohol at this temperature are respectively. Okay, so first of all, let's assume that I have a mole fraction of methyl alcohol. Okay, I will write here 1 second. Let XA be methyl alcohol. Okay, and then XB will be ethyl alcohol. Okay, so this will be equal to 1 minus XA. Now what I can write, P total is equal to P naught of A into XA plus P naught of B into 1 minus XA. Okay, according to Raoult's law. Now what is the formula here? P naught of XA, then I will have here P naught of B minus P naught B XA. Now if I take common here from both of this XA, so that will give me P naught A minus P naught B into XA plus P naught B, and that gives me P total. Okay, now according to my equation, this P naught B value is 138. Okay, and we have P naught A minus P naught B is equal to 120, right? So that means this is 138, so P naught A is equal to 138 plus 120, that is equal to 258. Okay, now the question has asked for, see, the question is slightly tricky. It is asking first of pure ethyl alcohol and then of methyl alcohol, right? So pure ethyl alcohol is my PB. PB value is 138 and PA is 258. So it is 138 and 258. You can see similar option, you may get confused and take the wrong option here. Next question, we have the equilibrium constant for the given reaction. Now you can see that how this reaction is actually obtained. COO So this is actually CO, like cobalt. Okay, now if I reverse this reaction and add to the first reaction, so if I reverse this reaction, I'll have CO plus CO2 gives me COO plus CO, right? Now if I compare this reaction and this reaction, COO will get cancelled, cobalt will get cancelled, and the remaining thing that we have is CO2 plus H2 gives CO plus H2O, right? I think that is what is remaining. I'll just check. I have here yes, so I have CO, so all these things are cancelled, so I have CO2 plus H2, and on this side I have CO and H2O, right? So what I have done, I have reversed this reaction and added with this one. So when you reverse this reaction, the equilibrium constant become 1 by 490, and when you add this one, you have to multiply with the equilibrium constant. So now we have to solve this 67 by 490. So if you see 7 sevens are 49, right? So I'll have 70, and 7 nines are 63. So 67 by 7 will be somewhere around 63. I have 40, then 7 fives are 30. So 9.5 here, right? So 9.5 divided by 7, if I do, like I can write it as 95 into 10 to the power of, this is minus 1 and this one is there, so minus 2 divided by 7. So 7 ones are 7, again I have 2, so 7 threes are 21, 4 will remain, 7 5 7 sevens are 49, right? Again we have two decimal places here, so that will give me 0 point, okay, 1 second, I will have just, I'll calculate like this, 67 divided by 490. Okay, I'll just divide this one directly because I got confused here with the calculation. So let me keep it simple. Here I have first 0 and 1 are 490. Okay, and you can see that there's only one option where you are starting with 1, so it has to be 1, and here also we got 1 3 something, so it is option number A here. You can complete this calculation. Next, for the reaction 3A plus B gives 2C plus D, the equilibrium constants of A, B and C are given. What is the initial concentration of A? Okay, so if you see the reaction is like 3A plus B gives 2C plus D. Okay, now let us assume that the concentration of A is somewhere A and this is B. Okay, and so A minus 3x will react here, and here it will be B minus 3 moles of A reacts with 1 moles of B, so B minus x. Here 2x will form and here x will form. Now the question is saying that A, B and C. So this 2x value is equal to 0.008. So x value will be 0.004. Okay, now we have the equilibrium concentration of A is 0.03. So that means A minus 3 into 0.004 is equal to 0.03. So if I solve here, it will be 3.012, that is equal to 0.03. Now if I add this one, I will have 0.03 plus 0.012. So that will be 0.042, which is option number C here. Next, which of the following is a correct statement? When mixture is more volatile, there is a positive deviation from Raoult's law. This is a correct statement because when volatility is increasing, the vapors are evaporating and creates a lot of vapor pressure. When mixture is more volatile, there is negative deviation. No. Ethanol and water form ideal solution. No, they form negative deviation. CH3, Cl and water form ideal solution. No. So option number A here. Which of the following represents the enthalpy of formation of water? So when the formation of there means it should always form 1 mole and in the natural state. So H2 exists in the form of liquid state. So if you see here H2 gas is correct, half O2 gas is correct, but here H2 gas is given, so this is incorrect. H2 gas, half O2 gas, H2O liquid, yes. This is the correct formula. Here what is the problem we have? Enthalpy of formation is given positive value. Enthalpy of formation is always negative. And here what problem we have? It is not for 1 mole. Okay. Now the most probable radius for finding the electron in the helium plus atom. So Rn formula is 52.9 into n square by z. Okay. Now if you see here, hydrogen, helium. For the n value will be 1, but this z value will be 2. So if I divide here, I'll get 26.5, which is option number C, right? 2 to the 4 takes, so 26.5 will be the answer. Next, we have to match here the formulas. So lambda m is kappa by C. So A has to 3, only one option, so I can go with B directly. G star is your what G star is cell constant, right? So B is equal to 1. Kappa is equal to rho into L by A. Sorry, kappa is equal to this one, and R is equal to rho into L by A. Okay. Next, we have which of the following statements state the law of multiple proportion. So law of multiple proportion is used when we have two different elements combined to give you more than two products, right? So carbon forms two oxides, CO2 and CO, and the masses of oxygen combines with the mass of carbon are in the ratio of 2:1. This is law of multiple proportion. Next question is from thermodynamics, where the pair of compounds soluble in water. Now remember, whenever the hydration enthalpy is more negative, then is if you add hydration and lattice enthalpy, if you are getting a negative number, in that case the solid will be soluble. Now if you see first option, this is more negative, so this one will be soluble. Now if you see second option, lattice enthalpy is more, if I add this two, I'll get a positive number, so this is not soluble. Here you can see this is more negative, so this will be soluble. Here this is positive, so this will be not soluble. So we have just P and R, which is option number D here. Next, activation energies of two reactions. This is very important question. Are EA and EA dash. Okay, two reactions are there. For first reaction, activation energy is EA. For second reaction, it is EA dash. And EA is greater than EA dash. Okay. As temperature increases from T1 to T2, which is correct. Now see, whether temperature you are increasing, definitely when you increase the temperature, the rate will increase. But when activation energy of EA is already higher, suppose its rate constant is K1, its rate constant is K2, then obviously K2 will be greater than K1. And at higher temperature, also K1 dash will be greater than K2 dash. So I have this relation in option number B here. Next, 4 gram of magnesium is burnt in 2 gram of O2 gas. What is the amount of MgO formed? So if I have this reaction, 2 Mg plus O2 gives 2 MgO, right? So now this is 48 grams and this is 32 grams. So we have 48 grams of Mg reacts with 32 grams of O2. Now 1 gram of magnesium will react with 32 by 48. Then we have 4 grams of magnesium that will react with 32 by 48 into 4, right? So we have here, then again I can cancel 4 3s are 4 8s are, so you will get 2.6 something, right? But oxygen mass is already 2 gram. It is less than, we require 2.6 gram, but we have only 2 grams. So oxygen is the limiting reagent. Now the amount of MgO formed will depend on this oxygen. So I can say that 32 gram of oxygen will form here 14 to 80 gram of magnesium oxide. So one will form 80 by 32, and we have 2 grams here, so 2 grams will form 2 1s are 2 16s are 16 5s are, so 5 gram, which is option number D here. Next, 0.1 of acetic acid is titrated, again 0.1 m of NaOH solution. Difference in pH between 1.4 and 3.4 stages of the neutralization of the acid. Okay, so now what happens here is, if you see this reaction, CH3COOH plus NaOH will react to give you CH3COONA plus H2O, right? Now if you see, when 1/4 reaction has happened, okay, so that means see how much is remaining then. At suppose you have here 0.1 m of NaOH is there, okay, and 0.1 m of acetic acid is there. Now when 1.4 of the acid has been consumed, okay, 1.4 of the acid has been consumed, then at that stage, like I will write at 1/4, at that stage the acid remaining will be 1/4 has been consumed, so 3/4 or 0.75 will be there. And how much has consumed? 0.25 has been consumed, so that much the salt would have been formed. So what is the pH value when at 1/4 stage? It is pKa, right? plus log of salt by acid, so 25 by 75, so that is 1 by 3. Okay, now when you come to 3 by 4th stage, that means 3 by 4th has reacted, remaining will be 2.5. Now if 0.25, so if 0.75 has reacted, formed here will be 0.75. So what is the pH at this case? pKa plus log of salt by acid, so 75 by 12, so log 3. Now we can take the difference between these two. If you take the difference between these two, you will get pKa plus log of 3 to the power of minus 1 minus sorry, pKa plus log of 3. Right, now pKa will get cancelled here. Then I have this one here, minus, so pKa, what's the formula of pH? pH is equal to pK, so this is correct, right? So minus 1 of log 3, and here also minus log 3, so that gives me minus 2 log 3. Okay, so here actually small error is there, this is minus 2 log 3, so option number D here. Next question, changes in the system from initial to final state were made by different matter in different manner, then H plus H value remains same, but Q changes because H is a state function and Q is a path function. Next, at 25 degrees Celsius for combustion of 1 mole of benzene, this is the value of delta H. Calculate the heat of reaction at constant volume. That means it is asking you to calculate delta U here. Now you can see delta H is equal to delta U plus delta NGR into T. Okay, now what is the value of delta H? So I'll just write down the formula for delta U. Then it is delta H minus delta NGR T. Okay, now what will be the value of delta H? It is 780980 minus delta Ng, means gaseous products minus gaseous reactant, so that is 6 minus 15 by 2, so that will give me minus 1.5, right? So minus 1.5 into R value is 2 and the temperature here is 25, so 298 Kelvin. Okay, so this one will be giving me 3 into this one, so 3 is 24, 3 9s are 27, 28, 29, 3 2s are 6, 7, 8. Okay, minus minus I can okay, here one more thing, the enthalpy of combustion is always negative. Okay, so this one has to be negative. Now minus minus is positive, so minus 780980, and this side I have 894, so 10 minus 4 6, 17 minus 9 is 8 here, then 0, again I have 0, 8 and 7, right? So that will have, we have here 3 decimal places also, I think. No, okay, 780086 we will get. Now to convert it into kilocalorie, here one decimal will come, so option number B here. Next, at 550 Kelvin, Kc for this is given. At equilibrium, we have this relation. What is the value of Z in mole inverse? Okay, so if you see, Kc value will be concentration of Z divided by concentration of X into concentration of Y. Now here we have 10 to the power of 4. Z concentration is already there. Now you have X is equal to 1 by 2 Y is equal to 1 by 2 Z. So what is the value of X in terms of Z? One second, we have to find the okay, so what is the value of X in terms of Z? It is 1 by 2 Z, right? X is equal to 1 by 2 Z, so 1 by 2, or I can write Z by 2, right? Next, what is the value of Y with respect to Z? It is just G, because 2 will get cancelled, so I can write this one and this one will get cancelled, so I will have 10 to the power of 4 is equal to 2 by Z, or Z will be equal to 2 into 10 to the power of minus 4. This was a simple question, option number A here. Next, 2 moles of an ideal gas is expanded isothermally and reversibly at 300 Kelvin from 1 liter to 10 liter. The enthalpy change in the reaction. Now, whenever isothermal process is there, delta U will be equal to 0, and delta H is also a function of temperature. This is also 0, so option number D here. Next, to which orbit does the electron in the hydrogen atom jumps on absorbing 12.1 eV of energy? Okay, so we have hydrogen orbitals here. right? Now the hydrogen in its ground state, okay, has an energy of 13.6 eV. Now you have supplied 12.1 eV, right? So that gives me how much? 6 minus 1, 5, 3, 1.5. Okay, I'll just check the calculation. Yeah, so which energy is having that, like which orbital is having that much energy? So minus 13.6, okay, by n square is equal to 1.5. That is what we have to calculate. Okay, so n square will be equal to 13.6 by 1.5, right? Or I can write 136 by 15. Now if you see 15 nines are 9 fives are 45 is almost around 9, right? So that means n should be equal to 3 here, which is option number B. Next, consider the following which is not possible. This is a favorite question from KCET. So we have to check which is not possible, right? So if you see n is equal to 3, so L can have 0, M can have 0. Here if n is equal to 2, L cannot be 2, it has to be 0 and 1. So 2 is not possible. Here these are all possible. This is, if L value is 0, then you cannot have minus 1 here. So this is also not possible. Here n is 3 and L is 2, then you cannot have plus 3, it is minus 2 to plus 2. So this is also not possible. So 2, 4 and 5. Is there any option? Yes, option number B here. Next, Venter factors of x, y and z are given. Which is correct? Okay, so Venter factor, boiling point. So if the Venter factor will be more, then boiling point will be more, right? So x is 2.8, y is 1.8 and z is 3.5. So that means z should be highest, then you should have x, but here it is y given, so this is incorrect. Freezing point. Now remember, if the I value is more, then depression will be more and freezing point will be least here. So z is having the highest value, so it should have the least freezing point, then x and then y. So this is the correct one which is given here. Next, the average osmotic pressure of human blood is 7.8 bar at 27 degrees Celsius. What is the concentration of an aqueous solution that could be used in the bloodstream? So we can just calculate here. Pi is equal to C into R into T. So if I have 7.8 bar, C concentration is there, R value will be 0.08 to 1 and temperature is 300, right? 27 plus 273. So that gives me 3 ones are 3, 3 twos are 6, 3 are 24, 3 0. Okay, and okay, sorry, I have two more decimal places also. So I have 1, 2, 3, 4. So 24.6 something I'll get. So 77.8 divided by 24.6. So that is equal to C here. So 78 divided by 246, right? So if you see, we have, how can I calculate? I'll just check this calculation once again. Okay, 3 ones are 3, 3 twos are 6, 3 eights are 24, 3 is plus 2, and I have 300, so I'll add 2. So 4, 1, 2, 3, 4. Yes, 24.6 and 7.8. Okay, now one more important thing here is, I'll tell. Okay, now you see this is actually what this is, NaCl, right? NaCl has also I value. We should not forget that. Here I value should also be there, and that is 2, right? So this 2 will also be divided here. So I will get 3.9 divided by 24.6, or I can divide 39 by 246, right? So now you have to just take 1 here, 246. So you can see only one option is there starting from 1. So that is the answer. Next, nitrogen and hydrogen in the molar ratio of 1:3 was allowed to equilibrate if 50% of each of the reactants at total pressure P, then Kp for N2 and 3H2 gives 2NH3 is. Okay, so we have this reaction, N2 plus 3H2 gives 2NH3. This is the reaction. Okay, now 1:3 ratio, so let this be 1, let this be 3. Now we have 1 minus x, this is 3 minus 3x, because 1 mole reacts with 3 moles, so x moles will react with 3x moles, and this one formed will be 2x. Okay, just a minute. If 50% of each of them has reacted, okay, so 50% means you will have x will be 0.5, so this mole will be 0.5, 3 minus 0. This will be 1.5, and this one will be 1, right? 2 into 0.5 will be 1 here. Now what I can calculate here is n total. N total will be 3 here. So what is the mole fraction of N2? mole fraction of N2 will be 0.5, that is moles of N2, right, by 3. Yes. Now, mole fraction of H2 will also be 1.5 by 3, and mole fraction of NH3 will be 1 by 3. Okay. Now what we have to calculate, the partial pressure. So partial pressure of N2 will be 0.5 by 3 into P. Now what is the partial pressure of H2? It is 0.5 into P, because this I can cancel. And partial pressure of NH3, it is equal to P by 3. So now let me just write down this in terms of fraction. Okay, so this one will be 0.5 means 5 by 30, or I can write 1 by 6p, right? This one is 1 by 2p. I'm just writing it so that calculation will be easier. And this one is 1 by 3 into p, right? Now I can write down here. So here I will have 1 by 3p square divided by n2 is 1 time, so I have just 1 by 6p, and then I have here 1 by 2p cube, right? So 3 and 4 we have, so I'll just arrange this one. This is 1 by 3p square, and we have, sorry, 1 by 3 into 1 by 3 here, and this one will go up, so I will have 6 by p, and here I will have 8 by p cube, right? So here p square that will get cancelled, and I will have just p here. And if you see 3 ones are 3 twos are, you can cancel here, and I will have 16 by 3 p square, which is there in option number A here. Okay, next we will move to question number 32 here. That is H2O is given, delta S1 and delta S2, predict which is correct. Now when you are doing in the gaseous state, okay, in that case the entropy is definitely much more higher, so delta S1 will be greater than delta S2, because we are going from liquid to gas here. Next, assuming 100% ionization, the increasing order of freezing point is. So just now we discussed, if the I value is very higher, then the freezing point will be less. So here the I value is 5, here it is 3, and we have just, and here we have 2, right? So since the I value here is maximum, the freezing point will be minimum. So this one will be minimum, then this one, then this one. So option number A here. Next, value of the equilibrium constant for the reaction here. So if you see Cu2 plus 2, Cu is undergoing reduction, Sn is undergoing oxidation. So what is the E naught of the cell? It is cathode minus anode. So copper minus tin. So copper is 0.34 and this one is minus 0.15, right? So that will give me 14 minus 5 is 9. This one will give me 0.19. I think I'm doing correct. Yes. Now what I have to calculate, delta G, that is equal to minus NF into E naught of the cell. No, sorry, I have to calculate the equilibrium constant. So we know that E naught of the cell is equal to 0.059 by N log of K. So this one will be 0.19, right? This one will be somewhere 0.03. Okay, I'll take it at 0.06. So I'll get 19 by 3 log of K. Okay, now 19 by 3, if you have 3 6 are 18, so 6.3 you will get here. That is equal to log of K. Now K will be equal to 10 to the power of 6.3. That gives me 10 to the power of 6 into 10 to the power of 0.3. Okay, now if you know that log 2 value is 0.3, so this one will be 2 and this one will be 10 to the power of 6. That gives me in option number C here. Next we have the calculation of kinetics part. So rate order we have to find out. So if you see, first I will keep this constant, okay, and I'm here, what I'm doing, I'm doubling this one. So with respect to this one, this is becoming 4 times. So with respect to NO2 minus, it is a second order reaction, and I can find that only one option is like that. So option number C is the correct answer. Next, under the same conditions, the initial concentration 1.386 moles per decimeter cube becomes half in 40 seconds and 20 seconds for zeroth order. The ratio of K1 to K0 is. So what you will understand, see, what is the value of K1? Means for first order reaction, it is 0.693 by T half. T half for first order given is 40. Now K0 will be A0 by 2K. A0 value is 1.386 by 2 into T half is 20. That is also 40 here. Now if I divide here, sorry, now if I divide One second, I'll just select the pen here. So if I divide K1 by K0, okay, if I divide this K1 by K0, it will be equal to how much? 1.386 divided by 0.693. So this one will be 2 3s are 6, 2 9s are 18. So you will get a value of 2. So option number D here. Next, 10.79 gram of silver deposited at cathode from AgNO3 solution. Same electricity is passed through copper sulfate using the copper sulfate electrodes. Weight of copper deposited. Here we can use Faraday's second law of electrolysis. So mass of silver deposited, that is 10.79 by mass of copper deposited, is equal to the equivalent mass of silver, so 108, divided by equivalent mass of copper, that is 63.5 into 2. So now if I just multiply this one and cross multiply here, so 10.79 I can take it as 10.8. I have 63.5 divided by 2 into 108. So this one will be, I will have 30, 2 3s are 6, 2 1s are 2, 7s are 14, yeah, 31.75, and there's 1 divided by 10 also, so that will give me 3.175, which will be equal to 3.2 here. Next, during the charging of lead storage battery, the reaction occurred at, so anode gets oxidized here. So what will happen? Pb from 0 gets converted to Pb in +2. So answer will be B here, +4. Let's see the next question. The oxidizing power of chlorine in aqueous solution using the data is given. The energy of half chlorine plus Cl minus will be. So you can just add here half of dissociation enthalpy first of all. Okay, so half of 240 is 120. Then you have electron gain enthalpy, which is minus 349, and hydration enthalpy minus 381. Now if you solve this, you will get minus 610, which is option number C here. Next, we have 12 liter of H2 and 11.2 liter of Cl2 are mixed and exploded. The composition by volume is a mixture of. So if you see the reaction, you have H2 plus Cl2 gives you 2HCl, right? So if you have taken 12 liter and here 11.2 liter, so this one will completely react, but 0.8 liter of HCl will form. Now 1 mole of chlorine is giving you 2 moles of HCl, so 22.4 moles or double of HCl will form. So that is in option number C here. Next, 1 liter of hydrocarbon at 127 degrees Celsius and 1 atm pressure weighs 2.8 gram. It contains 10.5 gram of carbon per gram of hydrogen. Then the molecular formula is. Okay, so now this is a bit lengthy question. So first of all, understand what we have to do. We have to find the empirical formula. Okay, C and H I have been given. C is 10.5 gram and H is 1 gram, right? That is the relation between carbon and hydrogen. So if I just now divide it and calculate its number of moles by 12 here and by 1 here. This one will definitely give me 1, but if I want to divide here, so I'll take 105 divided by 120. So here there will be 1 0 added. 900, 9 2s are 8, 9 will be too much, so I'll take 8 here. So 8 zeros are 0, 8 2s are 16, 8 2s are 16, then I have 8 0 0, 8 was 8 1 8 plus 1 9, right? So 0 15 minus 6 is 9. So that's all I think I have. Yes. Now again, if I take one more decimal, so again you can take 0.87. So this one will give me 0.87 and this one will give me 1. Now to convert it into a whole number, you have to find a multiple to, so that you will get here. So I can multiply this one with 7 and this one also with 7. So if I multiply both with 7, what I will get, sorry, I can multiply this one with 8, this one with 8, so that I can get a whole number. So you see 8 7s are 56, 5, 8 8s are 64, 64 plus 5 is 71. So 7.1 I will get here and I will get here 8. So C8, sorry, C7H8 is the empirical formula. Now what is the empirical formula mass here? Empirical formula 12 7s are 84, 84 plus 8, this one will be 92. Empirical formula mass is 92. Now we can find the number of moles here, PV by RT, right? So what is the pressure given? Pressure is 1 atm. I'll write here 1 atm. Okay. Volume is 1 liter. R value is 0.0821 liter atm, mole inverse, Kelvin inverse, and temperature is how much? 127. So 127 plus 273, that will give me 400, right? So I have to solve this. Okay, so this is a lengthy calculation. You can see 400, I can write it as 10 to the power of minus 2 so that I don't have to worry about that. And I have 0.08 if I just consider 4 8s are 32, 4. So I will have 0.32. So now we have this one, I can write by 100 by 32. So if I just divide 100 by 32, so I will get here 3 times 3 2s are 6, 96, 4 again, so 40, so 3.18. Okay, so that will again be 3 point, sorry, 2 2s are 4, 2 3s are 6, so 3.12 can be taken. So I will have 100 divided by 32 into 10 to the power of minus 2, right? So I'll get 0.0312. Okay, so this is the number of moles here. Now you know number of moles is equal to given mass by molar mass. Now in the given question we have 2.8 gram as the given mass, so 2.8 divided by 0.03. Okay, 0.0312. so if I divide this, you can calculate, you will get around 9 3 is 27 something, so 92 you will get here. And if you see, the empirical formula mass is also 92 and the molecular mass is also 92. So the empirical formula will be C7H8. Next we have to multiply this one, sorry, match the following. Energy of the ground state of helium will be we have 13.6 or minus 2.8 into 10 to the power of minus 18 z square by n square. So ground state will be, here we have z square minus 2.18 into 10 to the power of minus 18 z square, right? Hydrogen, helium is 2 squares of 4. So 4 is a 32, 7, 4 2 is a 8. So 8.72. So A has to be 3. Which option is there? A 3. Okay. We can also check in terms because we have option for 4. So let's check if I'm getting in terms of 13.6 into 4. 4 6 are 24, 12, 13, 14, 4 1s are 4 plus 1 5. Yes, we are getting minus 54.4. So A has to be 4. So there are two options. I can eliminate these two, right? Now the potential energy, this value is a constant value, that is minus 27.2 ev potential energy. So B has to be 2. So this is wrong. This has to be the correct option. Next, N2 and H2 in 1:3 molar ratio at equilibrium. The total pressure is 10 atm. Mole fraction of NH3 is 0.6. The equilibrium constant Kp for the reaction is, okay. Now see, N2 is there, plus 3H2 gives 2NH3. Okay. Now let's this be 1, 3, this is 0. Now here it will be 1 minus x, this will be 3 minus 3x, and this one will be 2x. Right now the, okay, we have been also given with the mole fraction of NH3. So what is the N total here? You will have minus 1, 3 plus 1, 4, right? And minus 4 plus 2. So 4 minus 2x, minus 4 plus 2, yeah. So this is N total. Then what is the mole fraction of NH3? 2x divided by 2 into 2 minus x. I can just take common here. So 2 will get cancelled. That is equal to 0.6. Now x is equal to, I can multiply here 1.2 plus, sorry, minus 0.6x. So this side goes, if it comes this side, you will have 1.6x is equal to 1.2. So x is equal to 12 by 16, or you will have 4 3s are 12, 4 3 by 4, or that is 0.75. Okay, now if this is 0.75, then we can calculate all these values first. So 1 minus 0.75 will be 0.25. 3 into this one will be 0.75, I think, because I can take 3 into 1 minus 0.75, and that will be 0.25, and 0.25 into 3 will be again 0.75. Okay, next 4 minus 2x. So this one is 2 5s are 10, 1.5. So 4 minus 1.5 will be 4 minus 1.5 will be 2.5. Right, I'll just check here. If I multiply 2 5s are 10, 15, yeah. 4 minus 1.5, I will get 2.5. So I have got all the values here. Now the total pressure is given, so we have to calculate the mole fraction of each of them, right? Now if I see mole fraction of N2, okay, that will be 0.25 divided by 2.5, right? So 100 by 10, that will be around like 100 here, and that will be 10 to the power of minus 1. Now mole fraction of H2 will be how much? Mole fraction of H2 will be H2 value 0.75, right? So 0.75 divided by 2.5. So how can I write this? 75 by 100 into 25 by 10. 25 ones are 25 threes are. This one will get cancelled. So I will get here 0.3 mole fraction of H2. Now what is the mole fraction of NH3 that we have already given? That is 0.6. Now what is the pressures for each of them? So you have to just multiply with 10 for all the values. Now let's see the pressure, partial pressures of each of this. So P of N2 will be 1 and P of H2 will be 0.3 into 10. So that is 3 because the total pressure is 10 atm, right? So you have to multiply this pressure with the mole fraction, and P of NH3 will be equal to 6 here. So now what we have this formula for Kp. Now the question is asking the Kp for the dissociation of NH3, means this reaction will be reversed. So you have N2 and 3H2 on the right hand side and 2NH3 on the product side, sorry, on the reactant side. So N2 pressure is 1, H2 is 3, so 3 times, so I will have like this, okay, divided by NH3 will be 2 times, right? So 3 ones are 3 twos are 3 ones are 3 twos are, so I will have 3 by 4, that is equal to 0.75. So option number B here, okay. Now we will move to question number 44 here. 5.85 gram of NaCl is dissolved in 1 liter of pure water. The number of ions in 1 ml of the solution is. So if you see, first of all, molarity if I calculate, so molarity if I calculate, it is 5.85 divided by 58.5 into 1 liter, right? So that will give me 100 and we'll have 10, so that will be 0.1 or 10 to the power of minus 1. So I can say that 1000 ml, okay, has 0.1 mole of NaCl, or the number of ions will be 2 because each has 2 moles. Then in 1 ml it will be how much? 0.2 into 10 to the power of minus 3, right? Now number of, this is moles, number of moles I'll multiply 6 into 10 to the power of 23, so that will be 1.2 into 10 to the power of 20, okay, which will be option number C here. Next, according to collision theory, increase in temperature increases the rate of the reaction because the molecules have more energy than the threshold energy. This is also explained in your Boltzmann curve graph. Which among the following equation represents the Arrhenius equation? It is K equal to A by EA RT. Next, 18 gram of glucose is present in 1000 gram of the aqueous solution of glucose, it is said to be. So if you see 18 gram by 180 into 1000 by 1000, right? So this is 0.1 molar, option number D here. Which of the following reactions correspond to the enthalpy of combustion at 25 degrees Celsius? So for enthalpy of combustion, the reactant should always be 1 mole, okay? And here we have 2O2 CO2 plus 2H2O, okay? Here what I have, CH4, 2O2 is given liquid, so this is wrong. Here we have H2O given as gas, that is wrong. Here we have CH4 plus 2O2 gives CO2 gas plus 2H2O. This is given gas here, so this is also incorrect. So A has to be the correct answer. Okay, now let's see next question. A 200 gram of cricket ball is thrown with a speed of 3 into 10 to the power of 3 centimeter per second. Its de Broglie wavelength is. So if you see, lambda is equal to 6.6 into 10 to the power of minus 34. Okay, joule second, joule kg, meter square, second minus 2, and here I have second, okay, joule second. And then you have m by v, m is 200 grams, so I will write it as 200 into 10 to the power of minus 3 kg, okay. Then we have 3 into 10 to the power of 3 centimeter. Centimeter, if I convert it into meter, it will be 10 to the power of minus 2, right? 1 meter equal to 100 centimeter. Then we have meter second inverse. Now this second goes up, it will become S2, and this is minus 2, this all three will get cancelled. Meter will get converted to meter here, and kg will get cancelled. So now we have here 6, 3 into 2 is 6, 6.6 divided by 6 will be 1.1 here, okay. Now this two zeros are left, and this three zeros are left and this one is left. Okay, so I will have 10 to the power of so you can see this one is 3 minus 2 is plus 1, this is 2, so I have total zeros will get cancelled in the denominator. So I will have 1.1 into 10 to the power of minus 34 meter. To convert it into centimeter, multiply with 100, so minus 32 will be the answer here, option number A. Next, a mixture of ethyl alcohol and propyl alcohol has a vapor pressure of 290 mm at 300 Kelvin. Vapor pressure of propyl alcohol is 200. If the mole fraction of ethyl alcohol is 0.6, its vapor pressure at the same temperature. Okay, so total vapor pressure is 290. Now, vapor pressure of propyl alcohol is 200. Okay, ethyl alcohol mole fraction is 0.6. That means propyl alcohol will be 0.4 plus 0.6 into the p value. So 80 here, okay, for 80, so that will be 290 plus equal to 80 plus 0.6 p. Now this one will be 210 divided by 0.6 is equal to p here. So that will 2100 divided by 6. So 3 ones are, we have 3700 and 2 we have 350, right? So that is option number B here. Next, the region in the electromagnetic spectrum where the Balmer series appears is your visible region. Next, the reduction of potential hydrogen half cell will be negative. So we have this formula, E is equal to 0 minus 0.0591 by N, right, log of H2 pressure, like P of H2 divided by H plus. Now, if I want this to be negative, then this value should be more than 1. If it is more than 1, then the log value will come out to be positive, and 1 minus in positive will give you negative. So this value should be more than 1. Now let's check here. Here it will be 1 by 2, so that will be 0.5 less than 1, so this is not there. Again 1 by 1, so this one will become completely 0 here. So 1 my log 0 will get. Next, here you have 2 by 1. Yes, so if I have 2 by 1, that means I'll get a positive number here. So option number C here. Okay. Next, we'll have according to Bronsted-Lowry concept, mark the option in which the conjugate pair is correctly matched. Okay. Sorry. Yeah. If you see here, conjugate acid, if you want to calculate, okay, conjugate acid means that component should behave as a base. Suppose you want to find the conjugate acid of X, then this X should behave as a base. Base means accepting of proton. So if I want to calculate the conjugate acid of this one, then it should behave as a base, and base is acceptance of proton. So here I should get H2CO3, so this is wrong. Now if you see HPO4 conjugate acid I want to find out, okay, conjugate acid of HPO4 2 minus. In that case, what will happen? Conjugate acid of one species. That means that should behave as a base. It should accept a proton. So when this accepts a proton, you will get H2PO4 minus. Now conjugate base of this one means it should behave as an acid. It should release one H plus. So you will get PO4 3 minus. So B is the one which is correctly matched. Then which of the statement is false here? Okay. The correct order is BaCl2, KCl and CH3COOH. Osmotic pressure given is pi by MRT. Raoult's law, vapor pressure of component is proportional to mole fraction. Two sucrose solutions of same molality of different solvents have the same freezing point depression. No, when the solvent is different, freezing point depression will also be different. So that is why option number D here. So students, these were the top 50 questions from physical chemistry, and I hope you have revised all these questions, and stay tuned for the next video.